Okay, this 6 weeks we are going to start trigonometry. So we're going to start out real slow, kind of learning the different terms and how things work. This week we'll talk about sine, cosine, tangent, talk about radians, degrees. It's going to be kind of a lot just because y'all have probably never learned these terms. But this is kind of the basic part of trigonometry. You have to know what these terms mean and how to kind of change between degrees, radians. We'll talk about unit circles, stuff like that. You have to know this stuff to get into the trigonometry, if that makes sense. So we're going to talk about different terms. All right, let's just get started. So let's talk about angles. Whenever we talk about angles, you have an initial side, right? Your initial side always starts on that positive x-axis, okay? So we start at 0 degrees, that's 0, and then it goes counterclockwise from there, and that's your positive angle. So if I go to the positive y-axis, that gives me a positive 90 degrees, right? We always go counterclockwise. All right, the end of your angle is called the terminal side. So our initial side will start always on the x-axis, and then it'll go until it hits the end of that angle, of course. But that's called your terminal side. Terminal means end. So that's your end side. Your vertex will always be at the origin here. So it's going to rotate around your axis. Let's see, what else? Okay, if you go clockwise, so even though we're going in a different direction, you still want to start on the x-axis. You still want your vertex at the origin. Okay, but let's say we start here like normal, but we go clockwise instead. We go this way. Okay, let's say that is your angle. You're going to have a negative 90 degrees. Okay, so if you go clockwise, it's a negative angle. Okay, the next part of these notes is talking about rotations. If you think about one full rotation, or even like spinning, a full rotation is going to be 360 degrees. So if I start here and I turn around and I end up back here, it's going to be 360 degrees. I'm sure y'all know that. So 1 degree is 1/360th of a rotation. Okay. If we talk about acute angles, and y'all probably know these terms, an acute angle is going to be an angle measuring less than 90 degrees. So it's an angle that is less than 90 degrees. And you can write it out, less than. These are your notes, so whatever helps you guys. A right angle is going to be an angle that measures 90 degrees. An obtuse angle is an angle that measures greater than 90 degrees. Okay, and a straight angle, if you think about an angle that's straight across, that's going to be 180 degrees. So a straight angle is an angle that measures 180 degrees. Okay, so just going over some terms, making sure we're all on the same page. Okay, the next part of your notes talks about radian measure. The radian measure of an angle is the number of radius units in the length of an arc. Of that arc, I'm sorry. So it says the angle equals the arc length over the radius. Your arc length, we give it the letter S, usually, the variable S, and radius is the variable R. So your angle is S over R. And if you're looking at a circle and you have this angle here, you have it on your notes. The arc length is right here. And then you have your angle and your radius is here. Okay, so we have a couple of examples to try this out. Number one, we're going to find theta in radians. Theta is this little angle mark. That's theta. And that's at that's on the front page of your notes. By the angle, it has the different Greek terms. For those symbols, you have alpha, beta, theta. I'm sure a lot of y'all have heard those terms before. So we're going to find theta in radians. This formula is already in radians. So we aren't even, the next part will kind of show you how to go from degrees to radians. But right now, we are just going to use this formula. Okay, it gives us a circle. And to find our angle, we're going to take the arc length. And for this problem, our arc length is 3 over the radius. And here the radius is 2. Okay, and I want you to simplify your fraction if it can be simplified. And that's as simple as it's going to get. So 3 over 2 radians. And so you can write out radians, or sometimes we do that. Rads. So 3 over 2 radians. So number 2, it says if S equals R, find theta. Now theta, like we said, is S over R. So if those two numbers are equal, what would your angle be? What would your theta equal? And if they're the same number, just think about, just pick a number. If my arc length was 2 and they're equal, and so my radius is 2, what would that give you? It would give you 1. And that works for any number you pick. If they're the same number in the numerator and denominator, they'll cancel, and you have 1 radian. Okay, so now we're going to convert degrees to radians. So it says 360 degrees equals the arc length divided by the radius. So 2 pi r over r. And that's just using the formula that we talked about just a second ago in your notes. That theta equals the arc length divided by the radius, right? So this is saying, let's say we have a complete circle. Okay, we have 360 degrees. Okay, if we want to find the arc length, your arc length is going to be completely all the way around the circle. Well, all the way around once. So if you think about that whole circle, the circumference would be 2 pi r, right? If you go all the way around the circle, and then your radius would still be r. So if we were to simplify this, our radius, our r's, will cancel, right? R divided by r, those will cancel. So 360 degrees equals 2 pi, right? So this is showing you 360 degrees equals 2 pi radians. So if we're talking about a full circle, we're talking about, let's see, if I went a full circle, this would be 360 degrees, right? If I'm talking about radians, it would also be 2 pi radians. They're the same thing. They equal each other. So anytime you're talking about 360 degrees, you're thinking of 2 pi radians. They're two different types of measurements, but they're equal to each other. So saying that, if I cut this circle in half, let's say I go 180 degrees. I cut it in half, right? If I cut my radians in half, instead of it being 2 pi, now it's going to be just 1 pi. So, and we're going to talk about this more later this week, about the circle and the degrees and the radians and stuff like that. But the easiest two to remember is that 360 degrees is 2 pi and 180 degrees is pi. And we use this in our formula to convert from degrees to radians. So on the formulas box off to the right side, if I'm going to go from degrees to radians, okay, I'm going to take my degrees, whatever it gives me. If it gives me 270 degrees and wants me to change it to radians, I'm going to take that and I'm going to multiply it by pi over 180 degrees. And that's going to give me the measurement in radians. And I'll show you some examples here in a second. But the way I think of it, it's kind of like, I think y'all are in chemistry or physics or whatever, but sometimes you have to convert measurements. Let's say you have years and you need to convert it to days. You take, like if I have degrees here, I'm going to have degrees in the denominator, so they'll cancel out, right? So that's the way I kind of remember it. If I have degrees and I want to go to radians, I'm going to have radians on top, degrees on bottom. That way they cancel. Okay. If I start out with radians and I want to go to degrees, I'm going to have degrees on top and radians on bottom. That way those radians will cancel and I'm left with degrees. And I don't know if that helps you remember it or not. That's just the way I kind of think of it. But these are the formulas. You're going to have to know them. And they aren't hard. So it's not too much to memorize. And the more you do it, it's not really memorizing. You just know how to do it. Okay, so let's try some examples. Number 3 wants us to convert 225 degrees to radians. And it says leave it in terms of pi. So if we want to leave it in terms of pi, we aren't going to put pi in the calculator. Okay, so let's see, 225